Welcome to Easy BTech, your guide for BTech and beyond. In the today's lecture, we will discuss about common collector configuration of a BGT. Okay, students, you can see common collector configuration. Common collector configuration. For common collector configuration, as we know that collector is grounded or kept a common between input and output terminals. Between input and output terminals. Next, the structure is now it is base, it is emitter, it is collector, NPN transistor. Okay. Collector is grounded. Input is base. Output is emitter. Okay. Similarly, current gain factor gamma is equal to output current change in IE by change in IB. Okay, if you study this, if you draw the diagram, you can understand common collector configuration. You can take across this output is taken here to here, you will take output. Side is IB, or you may draw in this manner also. Here also you can draw. IE, this is collector, it is base, it is emitter. This current will call as an IB, this current IE, and the voltage here to here, this will call as VCE, VE, VBC, VBB. This is the common collector configuration. Input side is the base, output side is the emitter. This current is an input current, this current is the output current. Okay, to study the input characteristics, that is, this is I1, this is V1, I2, V2. V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. We know that H11 is equal to Hi, H21 is equal to Hf, H12 is Hr, H22 H0. From this we will write V1 is VBC. VBC is equal to HIC IB plus HRC VCE. Next IE is equal to HFC IB plus H0C VCE. Okay, these are the expressions. We will write V1 is a function of I1 comma V2. V1 is in VBC HIE HIC into I1. I1 is IB. By keeping constant output voltage, VC is constant. Okay. By keeping output voltage VC, VCE, VCE constant, we can plot a graph between IB versus VBC. Okay, that is, we will write VBC is equal to HIC into IB. We will write HIC is nothing but change in VBC by change in IB. It is the input impedance. And the plot, if you see, this is IB. IB is in microamperes. This is VBC. By keeping VCE constant, this is at VCE1, it is as an VCE2. Okay. Input characteristics. As VBC increased, IB tends to 0. This is from input characteristics. Output characteristics. This is an output characteristics keeping IB constant. Keep IB constant, plot a graph between IE versus VCE. Okay. By keeping input current constant, input current IB constant, note down the reading between what is an output side VCE versus IE. Okay, because in a transistor IE is equal to IC, both magnitude equal to milliamperes. IB is microamperes. Now if you draw the graph, this is IE, this is VCE, and the graph is similar to of common emitter configurations. This is IB constant. This is IB constant. This is a common collector configuration. Now, this is very important for you in exam point of view. Please students follow this instruction. Comparison of common base, common emitter and common collector configurations. Okay. Now, let's see the parameters. This is common base, it is common emitter, it is common collector. Okay student, the first parameter if you say input impedance. Input impedance. This input impedance means HI or HI, either HIE, HIB, HIC. Now for this common base is low, for this common emitter is medium to high. Medium to high. For common collector it is high input impedance. High input impedance. This we will call as a input impedance. Second one is output impedance. This is output impedance high for the common base. This is medium to high and this is low. Next, voltage gain. Voltage gain. Voltage gain is high. For this also high. That's less than 1. Less than 1. Next, current gain. Current gain less than unity. This is high. For this also very high. Next, current gain factor. For this is alpha. Alpha for a common base output current is IC by IE. Beta IC by IB. Gamma output current IE by IB. Next 6. Phase shift. For the common base 0 degrees. For this is 180 degrees. For this is 0 degrees. Applications, we use applications. We are using common base for radio frequency applications. Radio frequency applications. This is for audio frequency applications. Common collector is for impedance matching. Impedance matching. Impedance matching purpose. Okay, students, please follow these comparisons. Very important. Okay, students, easy BTech guide for BTech and beyond. Thank you. This is about just comparison of common emitter, common base and common collector configurations.